Welcome back to our channel ClassFly Community. So today is the lecture 6. Here we will be dealing with the topic carbon dioxide laser. And here we will know about the construction, working and the vibrational energy levels of a CO2 molecule. Okay, so without wasting more time, let's begin and let's know what is carbon dioxide laser. So, CO2 lasers belong to the class of molecular gas laser. That means this laser is the part of the molecular gas laser. Okay. Now, this operates in the far IR region. So, this laser operates in a very far IR region. It also involves a set of rotational vibrational transitions. So, here I have made in points so it will be clear for you to make the notes with the video also, as well as what is basically the topic is you will get to know. Now, we will move on and see that it was developed by C.K. and Patel in the year 1963. So this laser was developed by a person named C.K. and Patel, and it was developed in the year 1963. So now let's move on and see the construction. So first of all, we need a diagram. So here is the diagram. With that, we will move on with the stepwise. So the first step is a CO2 laser consists of a discharge tube. So this is the discharge tube and it is of the length 5 m, which is being stated here, and in diameter nearly 2.5 centimeter. So this is the first thing which you need to write in construction, that it has a discharge tube with a length of 5 meter and a diameter of 2.5 centimeter. Now the second is the tube is filled with a mixture of CO2, N2 and the helium gases in the ratio of 1:2:3. Now note that this C and O is in capital, this N also is in capital, and this H will be in capital. So this is CO2, that is carbon dioxide, this is N2, that is nitrogen, and H means helium, and it will be in the discharge tube. It will be filled in the tube, and this mixture will be in the ratio of 1:2:3. That means CO2 will be 1, N2 will be in 2, and helium will be in 3 ratio. Okay. So now the third point is the pressure inside the tube is 6 to 17 torr. Okay. Now the fourth thing states that also water vapor is added to this discharge tube. So here in this discharge tube we add water vapor. So what happens when water vapor additives help to deoxidize CO to CO2 in case CO2 molecules break into CO and O during discharge. So basically water vapor this water vapor additives helps the CO, that's the carbon monoxide, to CO2. Moreover, whenever the discharge happens, this CO2 breaks in, whenever in case of CO2 when gets break into carbon monoxide and oxygen. That's why we add water vapor in the discharge tube. Now the fifth point is the two end of the tubes are sealed with flat quartz plate. So these are the flat, there will be a flat quartz placed in both of the sides which function as Brewster's windows. So this one and this one act as a Brewster's window. Now that means that it will get the linearly plane polarized light. So this portion works as the Brewster window, that is the flat quartz plate. Now the next thing is that two optical plane mirrors are fixed on either side of the tube. So this is the tube, and in both of the side there is mirrors. So one is fully silver mirror, that means 100% it will reflect the light, where other is the partially silvered, that means it helps to transmit the laser beam. Okay, so these 6 simple steps is the construction for the CO2 laser. Now let's move on and see the working. So working also we need a diagram. So see, when the suitable voltage is applied across the two electrodes, a glow discharge of the gases is initiated in the tube. So here whenever we apply the suitable voltage, everything needs a voltage. We can't give 440 volts. So everything needs a suitable voltage. So we will apply a suitable voltage, and from here there will be a discharge of gases which gets initiated. Now the next is, during the discharge, electron gets free from the gas atoms and starts moving towards the positive electrode. So whenever the discharge happens, what happens? The electron moves to the positive side and it collides with N2, that means the nitrogen molecule in their path. That means whenever it moves to the positive side, it collides with that nitrogen molecules whenever they are moving to the positive charge in the path. So this collision belongs to the collision of first kind. Now the third point is, the N2 molecules are raised to the first vibrational level. So these nitrogen molecules move on to the first vibrational level, which is V is equal to 1, which is the metastable state. The process is represented as, so we will represent this process by E1 plus N2, E2 plus N2 star, where E1 and E2 is our energy values of the electron before and after collision. So one is before collision and one is after collision, and N2 and N2 star are energy of nitrogen. Molecules in ground state, V is equal to 0 and V is equal to 1 state respectively. So one is in the form when it was in the V is equal to 0 state and when it was in the V is equal to 1 state. Hence population inversion is achieved in V equal to 1 of N2. So basically you need to remember that the population inversion gets achieved when V is equal to 1 for the nitrogen molecule, and molecules stay for about 10 to the power minus 3 seconds to 10 to the power minus 2 seconds. So this is the half part of our working. Now let's move on and see what happens next in the working. There is a close coincidence in energy of 001 state of CO2 and V equal to 1 state of N2. So this portion is the CO2 and this portion is the nitrogen. So what happens in N2 star collides with CO2 at the ground state. So when the CO2 is in the ground state, it gets collide with the N2 star. Okay. This leads to the transition of CO2 to 001 state. So it moves to the 001 state. The CO2 moves to the state of 001, and then it excitation of N2 to ground state, and then there is an excitation of N2 to the ground state. This type of collision belongs to the collision of second type. That means there is a coincidence in energy of 001 state. That means when the CO2 is also in the 001 state, and then the nitrogen also in the when the nitrogen is in the state of V is equal to 1. So at that point of time there is a coincidence in the energy. So which leads to the CO2 level move to the 001 state, and the excitation of the N2 moves to the ground state. So whenever this happened, this was the collision of second kind, and 001 state is the metastable for the CO2 molecule. Hence the population inversion is achieved in CO2 molecule in 001 state. This process can be represented by N2 star plus CO2 and CO2 star plus N2, where N2 star and N2 are the energies of the nitrogen molecule, and in V is equal to 1 state, when V is equal to the 1 state and the ground state is respectively, and CO2 and CO2 star are the energies of the CO2 molecule in the ground state and the 001 state respectively. So let us designate the 010 state, 020 state. So this is the 001 state, 0 2 0 state, this is the 1 0 0 state, and this is the 0 1 0 state, this is the 0 2 0 state, this is the 1 0 0 state, and this is the 0 0 1 state. So this of the state is labeled as E2, E3, E4 and E5 levels. Now as we can see in the figure, so basically we can see all the working in our figure. So now let's move on and see that once population inversion is established in E5 level, the CO2 molecules undergo stimulated emission to E3 and E4 levels. So whenever these E5 levels get established, that means the population levels get established in this E5 level, it undergoes a stimulation of from to E3 and E4. So there is a stimulation which happens in the E3 level and in the E4 level. So the first is the transition from E5 level to E4. So once there will be a transition in the E5 to E4 with a wavelength of 10.6, which is in far off IR region. And the B thing which will happen is from the E5 to the E3 with a wavelength of 9.6 mu m, which is also in far of the IR region. So this happens when this E5 goes to the population inversion. Now molecules CO2 from E4 and E3 level undergoes inelastic collision with unexcited CO2. So molecules and de-excite to E2. So it gets de-excited to E2 when there is the inelastic collision happening between E3 and E4. So later this CO2 molecule in E2 level undergoes collision with helium and water vapor molecules and came down to the ground state E1. So CO2 laser has an efficiency of up to 30%. So in simple things, you need to remember that whenever there in the E5 there is a population inversion, it goes the collision. Whenever there is a population inversion, there is a stimulation emission in the E3 and the E4. One is that in the E4 the wavelength moves to 10.6 mu m and in E3 9.6 um, and the E5 to E3 we got from this to this. Okay, and the second thing which you need to remember that E3 and E4 goes in an elastic collision where it gets de-excited to E2 and then it gets and it collides with the helium and water vapor and it moves on to the ground state. Okay, now we will move on and see the vibrational energy level of a CO2 molecule. So carbon dioxide molecule has two oxygen atoms between which there is a carbon atom. It has, so basically the carbon dioxide molecule has two oxygen and in the middle there is a carbon, and it has three different modes of vibration. So let's see what are the three different modes of vibration. So the three different modes of vibration is symmetric stretching mode, asymmetric stretching mode and bending mode. In this mode, the oxygen atom vibrates along the molecular axis. So this oxygen and both of the oxygen atom vibrates in the molecular axis, either approaching towards the carbon. So it will either approach towards or it will depart from the carbon atom. So the carbon atom will be stationary, that it will be whatever the position of the carbon, it will be there only. Only the both of the oxygen will work. Means it will move. So either they will go towards the carbon or apart from the carbon. So this vibrational state is given by 100. That means this is the symmetric stretching mode. Asymmetric stretching mode means during the vibration in this mode, all the three of the atom oscillate along the molecular axis, but the two oxygen atom moves in one direction. That means both the oxygen either moves in this direction or it will move in this direction, but both of them will be in the similar direction, and the carbon atom moves in just the opposite direction. So as it is moving in the left, so the carbon atom is moving in the right. So if they are moving in the right, then the carbon atom would be moving in the left. This vibrational state is 001, which is the asymmetric stretching mode. And the last is the bending mode. In the bending mode, all the three atoms oscillate normal to the molecular axis. That means either in the up direction or in the down direction. Here what happens, these two oxygen atoms pull together. That means they will pull in the same direction as they were doing in the asymmetric. They were moving towards molecular direction in the same direction. Here they will be doing normal, that is in 90 degree. So they will be doing the same direction, and the carbon will be on the opposite direction. So the difference basically is asymmetric will be in the molecular axis and they will be same. The oxygen will be in the same direction and the carbon will be in opposite direction, and in the bending mode they will be normal to the molecular axis. The oxygen will be same but the carbon will be in opposite direction, and this bending mode is the state 010. So today's lecture ends here, and I hope all the points are clear, pretty much clear with the diagram. So you just need to remember all the points and note down it with the diagram. And till then, be happy and have a great day, and I will see you in the next lecture.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magazine videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.